Central Power session entitled Data-Driven Decisions for Reliability and Resilience. Before we begin, we'd love to say thank you to Southwire, who is sponsoring today's event, making it possible. We really appreciate their sponsorship. Now, I'd like to turn the floor over to our moderator of today's event, Mike Beeler, to kick things off. Mike, welcome to the event. You have the floor.
Thank you very much, PJ. Really appreciate it. Thanks to Energy Central for putting this together and for Southwire for sponsoring. We got a great lineup of speakers today to talk about data and how data impacts our industry. And we're going to talk about it in the context of resilience and sustainability, and then all the other things that we have to deliver in our industry, safety and reliability and performance and such, but with a real focus on sustainability and resilience. And with us today, you can see the lineup. We've got Mark Phillips from DEMCO, the Dixie Electric Membership Cooperative in Greenwell Springs, Louisiana. Got Ray Caston. Ray recently retired from Southwire. We got Wayne Chatterton, who is a vice president at Southwire, and Paul Bauer, also a vice president at Southwire. So what our format today is going to be is hopefully a conversation amongst these men and you, the audience. We're going to ask you as the audience to submit questions as we go. As the moderator, I certainly have questions in mind for these gentlemen. We'll give each of them 3 to 5 minutes to make some opening remarks and tell us what's on their mind and in the context of this topic in particular. And then we'll go to audience questions. I'll ask a question or two, and then we'll ask audience for question, and then we'll wrap up towards the end with some concluding remarks. We have 90 minutes, so we encourage you to have a seat and listen up. And we're going to start off with Mark Phillips. And Mark, glad you're with us. Thank you very much for coming. You're the Chief Engineering and Operations Officer at DEMCO in Louisiana. Give us a few opening remarks. What's on your mind today? And you know, you live in a world of reliability and resilience and sustainability and customer service. What's on your mind today, and why are you on this panel with us today?
Yeah, Mike, thank you so much for the short intro. So, you know, like I said, I'm the Chief Engineering Operations Officer here at DEMCO. Back in July, I just made my 24th year here at the co-op, so I have a lot of experience battling afternoon weather, thunderstorms, tornadoes, ice storms, snow, and hurricanes, of course, which is always, at the topic of everybody's mind in regards to reliability. I didn't take the traditional approach to the position I hold. I'm actually a lineman. Started on the line crew, restoring power and building jobs, doing all the really cool things line guys get to do every day. And just by chance and through, opportunities, I now reside as like you said, the Chief Engineering Operations Officer. So a lot of my job day to day it revolves around reliability. How can we make the grid stronger? How can we make it more reliable? What tools can we put in place that can allow us to achieve that as well? And that's kind of why I'm here today, is to share some experiences that I've had using some of the tools that Southwire provides. In a lot of ways, helping them develop the tools to meet the needs of the end users, so that we can do our very best to provide reliable service to our membership. So, as mentioned, very excited to be here, very excited to be a part of this, and I can't thank you enough for the opportunity.
Hey, Mark, that's a really great background. You come in, as a lineman. Let me ask you a quick question. We want to keep this conversational, guys, but I was talking to somebody today, and they said, is there a lot of difference between an overhead lineman and like an underground cable crew? And my answer was, you have to have a good understanding of the safety and and how electricity works. But then beyond that, there's probably, after you have that fundamental knowledge, there's probably a pretty good difference. How do you feel about that, being an old lineman?
Honestly, Mike, I think they're cut from the same cloth. You have to understand the way electricity flows from point A to point B, and then you have to understand the safety and associated with each different path that it takes. The only difference is you can't see what's in the ground, but you can see everything that's overhead. So as a lineman, we're tasked to troubleshoot both. So it's not really a segregation of duties. If I roll up on an underground line, I have to assume that that it's still electricity is still flowing. So I have to be careful and be conscious of all that. But if you can apply the concept that what I see overhead and what it takes to put it in the ground, and ultimately they got to get to the same point the same way. I mean, it's not really that much difference when you really dig down deep. Now, working on the line, of course, you have to have certain skills and to be able to do that. But ultimately, it's the same thing. You got to be careful, and you just gotta, you got to be experienced to do both.
Yeah, that's a great answer. Thank you. I appreciate that. I literally had to answer that question earlier today. Wayne Chatterton, I know you got a comment on that because when he says, well, you can't see the overhead, you probably got ways to see what's going down underground a little bit. I know you've got some thoughts on that. I'll just quick comment if you want on that, and then we'll get on to Ray.
Yeah, we can save it, but yeah, we have special tools, and I'll talk about that. We know what's going on underground. You need to know what's going on underground, but it's the same similar tools that you would use overhead. We don't use the term, you didn't describe what I would call a person working underground cable. We call them groundmen. They're linemen who don't have to climb a pole. But Mark is 100% right. They are they have to be cut from the same cloth. They have to know everything about electricity, and they have to have the same skill set. The craft work and stuff that they do is critical. So we still call them linemen, but they're really groundmen. They don't climb up the poles. That's the main difference. But the technology to look underground is very unique, and we can talk about that later. Okay,
Yeah,
Mike?
good. Yeah, thank you, Wayne, for chiming in. Okay, hey, Ray Caston, you're a recent retiree from Southwire, and you have got an opinion about the industry that we are eager to hear. Give us some opening remarks, if you would, please, Ray.
Yeah, firstly, my background, I started in the utility industry many moons ago in the nuclear side of the house, nuclear generation, providing enterprise asset management. It was a time when the utilities were having some challenges with reliability and unscheduled outages. And so we worked with a handful of utilities and then eventually 80% of them to help turn around the nuclear industry. After that, our company went public. So I was asked to join a company called CES International, which is now called Oracle NMS, their outage management, network management system. And that's where I ran into Paul. And one of the things that I learned was that because there were millions of assets of low value, everyone thought you run things to failure. And in the nuclear industry, where it was about RCM, predictive maintenance, listening with sensors and all that. When I met Paul, I wanted to kind of bring that knowledge about, hey, how can we eliminate some of these problems from even occurring? And of course, you're always going to have bad weather and all that stuff that goes on, and aging assets, which goes on. But there are certain things that you can do that working together with manufacturers out there, as well as customers and best practices, we're able to say, hey, listen, for that type of problem, we can design that out by putting this equipment in, or hey, if we do this type of technique, we can improve reliability quite a bit. And after the Oracle purchased CES International, Paul and I started up in the operational business intelligence world for the last 20 years. And as we were talking to Southwire about, okay, tell me about your wire, what's special about it, tell me about tree wire, let me spacer cable, things like that. Southwire became interested in what we were talking about and eventually acquired our company. So we're an acquisition of about 3.5 years. And what interests me is really that, the buzzwords here that we just brought up, reliability and resilience. And I think there's huge opportunities for us. And I just love the industry that everyone works together. It's not like two manufacturers going at each other, trying to be more competitive. Everyone's more collaborative.
It is a great time to be in this industry. You said a word or an abbreviation, RCM,
Yeah,
reliability
yeah,
centered maintenance, which is
correct. Yes.
basically predictive maintenance. So that probably came into our industry like in maybe the late 80s, early 90s, coming out of You said out of the nuclear industry. In a previous life, I did a project. A guy had come out of the Navy, and he wanted to apply reliability centered maintenance principles to the T&D system, and that was brand new in the industry. But we were looking at these predictive tools now. Fast forward, Paul, to 2025, and we're looking at some of these tools now that are very commonplace, where we're able to predict the condition. And we'll let you comment on that. But if you just want to interject on some of the couple things that Ray said, I'll let you just do that real quick before we go to Wayne.
Sure, sure. No, that was an important ingredient. I'd come out of the sort of the energy management, outage management space when I met Ray, and we started looking into the sort of business intelligence space. That discipline in the nuclear space was really important to what we were doing. You know, looking at how do we take all of this information that's being captured in these outage management systems and incident management systems, and turn that into something that we can use to derive, you know, where are the biggest problems, what can we do predictively to alleviate some of those, and then following that, after we got through sort of doing the reliability side of it, was, well, how do we actually get into proactively defining, as Ray was mentioning, what are all these different things you can do on the networks to improve their resiliency, you know, whether it's from a storm perspective or a blue sky perspective or a public safety perspective, what are the things that we can do to enhance that network?
Yeah, that's good. Remember, we used to talk about data to information to action, action in the field based on the data that we turn into usable information. Lots and lots of data, information that ultimately gives us something actionable. Okay, Wayne Chatterton, talk to us a little bit. You're vice president at Southwire. Give us some opening remarks and what's on your mind today.
Well, first, before I introduce myself, I've known Ray for a while. I consider him a dear friend. But the day I retire, we'll be changing my phone number, and don't call me, guys. I will be retired. I'll be out fishing or playing golf, and I will not be here. So, I have a PhD, Mike. I have a PhD in silicone chemistry, and I've been in the electrical industry for 35 years. I cut my teeth on transformer fluids, silicone transformer fluids, that were developed at Dow, where I started my career, to replace PCB in transformers. And then I don't know how it happened, but I became a circuit breaker lube expert, a silicone rubber development person for making rubber insulators. But I spent most of my time at Dow helping to develop cable rejuvenation technology and fluids. Now, the reason we look at all of this stuff is because of the topic we're talking about today, which is resiliency and sustainability. And what we've always said, two things I've always said, we're talking about data, right? If you're not testing, you're just guessing. You just have no idea what you're doing. So you need to assess the situation. And then you have an asset in the ground. As a utility, you have an asset in the ground. And that asset is your cables, your splices, your terminations. We have developed a method for injecting those cables in the ground and bringing them back to like new or better and making them last for a very, very, very long time. So that's the reason I'm here today. I'm passionate about sustainability, very much so. I don't want us to, our grid is, the increase of the demand on the grid is astronomical, as everyone on this panel, as everyone who's listening knows. I always give the example of a typical home in the United States uses 7 kilowatts of energy per day. To charge an electric vehicle like a Polestar or a Lucid or a Tesla requires 7 kilowatts of energy a day. Most homes have 2 cars. So if you have 2 Teslas in your driveway and you have your home, now you have a grid that was designed and operated around 7 kilowatts of energy a day that's using 21 kilowatts of energy per day per home. So keeping the grid resilient, keeping the grid sustainable, and keeping the cables and the assets that you have living a very long time is very important. And so that's my story. That's the reason I'm here. One thing I didn't mention, I wanted to mention, Mike, I think there's somebody from Guyana Light and Power. I was born in Guyana, in British Guyana in South America, and then I did my PhD at the University of Toronto. But I've been in the U.S. for 35 years working in the electrical industry. So that's me in a nutshell, Mike.
Great, Paul. Hey, Wayne, I tried as I might when we were on a time of use rate at Kansas City Power and Light, now called Evergy, to keep that 7 kW. I'd have been very happy with a 7 kW peak, but by golly, if they didn't run that peak up to 9 or 10 kW on
every
a hot
day.
summer day every day, it's like, come on, we're on a time of use rate here. It's like, I don't care. We
I live
gotta.
I live in South Carolina. I guarantee you, during the last month where it's been over 100 degrees every day, I guarantee you we've been over that 7, 9, 10 every day. I guarantee you.
Yeah. Yeah. And so we design our system accordingly. And that's one of the reasons why we're investing hundreds of millions, if not billions of dollars into the grid, which is a very exciting time. Okay, Paul, uh, give us some opening remarks, if you will. We've already got to meet you a little bit, but go ahead and give us what's on your mind.
Sure, sure. I'll do just a touch of background as well. I've been in the utility space since the late 80s. As you kind of mentioned, that's kind of when some of this began. You're sort of bringing together data and technologies. And so I've been involved since then. That's when we kind of kicked off the outage management world and outage management systems. And then, as Ray was mentioning, we got together following that and got involved in business intelligence. And a couple of the things that we were really focused on. One was this sort of reliability sort of focus and what can we do with reliability information, but also sort of a near real time awareness of outage activity outside of the sort of the normal control room, storm room. So providing solutions that got that real time or near real time information out to a broader audience. That was kind of an important ingredient there. And then we started looking at as the third one was kind of what can we do with all this reliability information to start looking at how do we optimize sort of data-driven actions to directly improve grid resiliency? And that's what we ended up with and what Southwire picked up. So, today in my role, I really focus on sort of integrating disparate data, utilizing a lot of information around spatial intelligence and leveraging AI to enhance that grid resiliency and operational performance. So I know we talk about resiliency and sustainability, and they're not really just sort of buzzwords, but they are, as we've seen from the industry and stuff, they're outcomes that we can engineer into the system. We believe we can take this sort of productized approach to designing and innovating and collaborating with our utility partners like Mark and others, where we can bring in their needs and understand that. When we talk about grid resiliency improvements, it's kind of a pretty broad range. There's a lot of things that can be done, and it can get very complex with all of the systems and things that can be performed. So the idea is to sort of bring these together, whether it's modernizing the equipment, like introducing cutout mounted reclosures, or looking at strategic undergrounding or things like that, or network optimization strategies like resolving phase imbalances or addressing miscoordination or segmenting circuits, introducing additional smart grid, sensors and devices. Another area is improving assets, sort of mitigating your defects or encroachments or other things of that nature. And then obviously, one of the big ticket items too is that vegetation spend and that vegetation program. How can that be optimized? And so the notion here is it's a very complex area, and different sort of groups can work in different areas and different tools support those. And what we want to do is kind of bring those things together. The next slide, if you want to just pop that up, the next slide.
So, Paul, let me ask you a quick question.
Sure.
So did I hear you correctly? You can come in and make an evaluation of somebody's system and look at how they're currently operating their system and say, you know what, you're missing this key electrical piece of equipment that you don't have on your system that you should add. And if you'd add it, we can engineer in better reliability or better resilience onto the overall system. Resilience, for example, in the case of like strategic undergrounding. So you're
Yes, yeah.
suggesting that a guy like Mark may not even have it on a system, but you come in and you can evaluate something that Southwire may or may not even sell to say, put this on your system and you can improve your performance metrics.
Yes, yeah. It may be sort of combination. It could be something that Mark hasn't seen, but it could also be something that Mark's sort of looking at as well and maybe piloting, looking at a few items.
Okay.
What we would do is go in and say, well, if you broadly place this out there, where would be the best places and what kind of return can you get for that? So kind of a combination of maybe new things as well as what would you expand with existing practices?
Maybe something that Mark's already piloting and is thinking about already, but then how would I apply it on my system? Where would I prioritize the installations and such?
Exactly.
By the way, I think Mark could probably talk to this best, but there's a lot of data sources right here. But to get started, basically, if you have GIS and OMS data, you can do an assessment in about 2 or 3 weeks. Mark, you probably want to add to that if that's okay.
Yeah, for sure. So it's super important that you have a very robust GIS system because that GIS map actually is the base layer of your OMS map, right? So everything that you have in GIS can reflect in OMS. And to Paul's point, when we're looking at our system, it's just a one-line diagram, right? It's 2D. And if I want to build coordination standards or I want to develop a new practice that I want to employ across the grid to increase reliability, well, there's going to be some blind spots in that data because I've got to go line by line by line to determine if I have the right, the device that I assume that I want to put there. Well, with the Southwire product, I mean, I could cut and slice that data in a matter of seconds, and it actually tells me where it recommends based off of certain criteria that a good possible candidate for this, for this solution. So it's, man, I can't say enough about the data and bringing the OMS data and laying it back on top of your GIS data so that you can analyze it easier. That the visual behind that is in my opinion is worth its weight in gold, and we've benefited immensely from that since we've employed this application.
So one of my takeaways on that, Mark and Ray and Paul, would be that you've got to have something as simple as a GIS system to be able to be in position for some of these new opportunities, maybe some of these emerging technologies even that are coming to bear in the industry. So there's some fundamental basic things you got to do, and geographic information systems is one of them. Is that a fair, Paul? Do you think it's fair to think that most utilities have that in place? Is that it's 2025? Shouldn't most utilities have that in place already?
Absolutely, absolutely. Yeah, GIS is quite common out there these days. And remember again, it goes back to those early 90s when these were being set up, being digitized and brought in to the system. So yeah, it's quite prolific out there, as well as outage management systems. We're seeing a number of different, actually generations in a sense of outage management systems again since the beginning of the early 90s, putting those in place. So those two are pretty critical ingredients as far as data sources, and all the other things kind of can now be glued to that and brought in and enhance that solution and analysis.
Well, Paul, why don't you go ahead and wrap up your opening remarks here? Ray, did you have a comment?
No, I was just going to add that on the, as Mark was bringing up about the GIS, that connectivity model tells you the importance of every asset in the field. So if I'm at the end of a circuit, it only maybe one farmer that has his own little backup system is going to be affected. It's a lot different than, hey, this fue's going out that may drive 2 hospitals and a school system or a pump storage station. So there's a lot of value in every one of these data sources that we'll be hopefully talking about.
Mark,
yeah, and some of the other one other element on that data is, a lot of data is captured in notes and comments, operator notes, crew comments, things like that, customer comments as well potentially, and those things can be really valuable. So I mentioned earlier, the application of AI that also helps us to codify that data that's in those systems as well, and add additional value to the data that we're giving, and look at validation and some things like that as part of that data process. So it looks like a lot of sources, but as Ray was pointing out, and Mark, you can start with 2 of those, outage and GIS. That gives you a tremendous amount. The rest, again, just augments that. If we go to the next slide, it just talks a little bit about the process here that we go through. And that process is really, one where we look at, what is the risk of failure? Where are the places where there's potential impact? And again, knowing the network topology, we know something happens at one location. Well, what's the impact of that failure? Is it going to trip the entire circuit? Is it going to trip a certain spot? And then also using that outage data and analyzing that data using AI techniques and others, what's the root cause? What really happened to cause this? And then what we want to do is then sort of give you a nice visual capability to see, well, how do those problems match up with the potential remedies that I could do? What's the ranking? Which ones give me the better cost, the better reliability, the better safety? What kind of margins do I get out of those practices? And then basically enable you to do that work, measure the benefits that you're achieving, and then sort of wash and repeat, right? Rinse and repeat, and just keep enhancing that system through this process, being able to introduce new tools, new techniques, new methods, but kind of following this data-driven process. So, for me, the last thing, again, it gets back to, these improvements, should be driven by, that are driven by reliability and safety. And we've talked about customer demand and this changing load mix, from Wayne, all the things that are happening out there, as well as, sort of financial pressures too. We believe that there's really a dynamic solution that provides this ongoing analysis, that can adapt to these changes and measure the actual results. And then you use those results to further refine their strategic and tactical plans. That's kind of what I want to leave you with. That's sort of the focus of what we try to do here with these solutions.
That's a great intro. I want to come back to you later, Paul, and ask you about measuring the benefits. I think, how do we quantify the benefits? How do you quantify resilience, which I would say we haven't figured out as an industry how to do yet, but we need to start moving in that direction. So we'll come back to quantifying or measuring the benefits and making decisions. Okay, so we're going to go back and to our panel now that everybody's had a chance to say some opening remarks, and we're going to come back with a couple of questions for each of these gentlemen and get their comments. Again, we want to keep it conversational, so I'll say to each of you, if you want to interject something, feel free to, and then audience, feel free to send in some questions as well if you want to see if you got a particular direction you want this panel to take. But Mark, so Paul was describing some of the cool things they're doing. Is there an example on your system? You got 120,000 meters, you're in Louisiana, you're an EMC. Is there an example of something that you've had done on your system specifically with this concept of going in and evaluating and making a determination? Maybe you were piloting something. Maybe you had a vendor that said, let's pilot something. What has caused you to have a working relationship with these guys at Southwire?
Yeah, so ultimately, we're chasing the golden carrot, right? We're trying to reduce our safety because that's ultimately how electric utilities are measured, But as mentioned, we're down here in South Louisiana. We don't have a very good safety. So what's common for folks across the U.S., we don't. So we have to be innovative. We have to do things like we have to employ distribution automation and electronic reclosing and all these other things that cost a lot of money.
Would you say you're an overhead or underground utility?
We're both. We're 9,200 miles of distribution line. 230 miles of that are sub-transmission. We're not a transmission owner, but we have transmission, the 69 kV that runs between our substations. We have 10 different metering points that we attach to the MISO South grid, and 44 substations. So we're a fairly large cooperative.
A lot of substations.
Of those 9,200 miles, about 6,500 of them are overhead and 2,500 are underground. So we have about a 60-30 split there, But just jumping back into, like I said, the question, when we got involved with Ray and his team and Paul and his team with our data analytics, we've got 20 years of OMS data, right, that we have been storing in the background. Everything that we do in the field as far as restoration effort is we record. So when we brought Ray and Paul's team on to open up and investigate, what their solution could do, we gave them that 20-year data dump, and automatically the veil was pulled to the side, and we were able to really see and dive deeper than you would if you just had a tabular Excel spreadsheet with a bunch of information. It actually started exposing things to us, right? Like areas where I may have had a traditional fuse lateral tap, and that tap may have blown 10 times this year, and if all 10 different guys don't get together and say they had that outage, then the only person suffering is the member on the end of that line. So it brings the data in and shows redundant are repeat offenders. So in those instances, we may go back and say, okay, well, I've got this new device that I'm piloting. You talk about new things. Electronic fusing is something that's new, not reclosing, just electronic fusing. Well, that tap may not warrant a recloser, but it would warrant, me to install a sectionalizer, which is electronic fusing, which I get 2 shots instead of 1. But the software then is exposing those areas to me. And since we have deployed the software, we are now creating coordination standards here that we've never had before. Like, what is our criteria that we're going to have to meet before we determine whether or not we want to deploy a certain resource out onto the system? Prior to that, it was just hearsay. It was just conversation and comment, or let me think if I want to do this or not. I think I want to do this. Somebody wants to try something, but maybe I should, maybe I shouldn't. Well, we're now justifying the expenses with data, right? And that's what the software solution has done for us. And then after we've installed it, we have a measurement of before, and now we have a measurement after, and that's that benefit cost analysis, right? Or are we employing the right tools on the system, and are we getting the benefit? Because ultimately, the member experience is what I'm trying to elevate. I'm not really trying to elevate, whether or not it's, money is important, but for DEMCO and cooperatives across this country, the members own us. So the member experience, if they've got good, reliable service, well, they're willing to pay a little bit more for it. So the software kind of helps me justify those expenses.
Yeah, that's well said, and I'm glad you said that about co-ops. I feel that way about public power and cooperative power, that you really are closely tied to your customers. And not that an IOU isn't, but I just feel like there's a much closer personal connection there. Paul, I'm going to come to you because he said something about data, and we're going to take this 20-year data dump, and it's like, okay. And people find data in different, conditions. It's been well curated. It hasn't. It's got inconsistencies in it. So with all this data integration, which sounds pretty fundamental, and it sounded like at DEMCO it worked out pretty well for you guys, how do you deal with data quality issues? And then Ray, I'm going to ask you to comment on that as well. But Paul,
Yeah,
what do
so
you
that's
think
that.
about that?
Sure. That's a huge element. And actually, it's one of the ones that I know, creates a lot of worry in some senses of, can I do this? Do I have the data and a quality that I can accomplish these kind of things with my systems? And so, we hear that quite a lot. And our approach is always, give us your data and we'll kind of tell you what we see. So one of the main ingredients in our system is a data validation, data integrity type solution. And over these years that we've worked with data, whenever we've gone in and found a problem and looked for resolutions of that problem, whether it's fixing source or mitigating that data, we kind of bake that into the solution. So there's a rich set of things that we want to look for to find problems in data. As I mentioned earlier, one of the things that can also play a big role in finding what really happened there is some of this AI, natural language processing. And I sometimes coin it as it's sort of unnatural language because it's a lot of operator speak, a lot of acronyms, a lot of different ways to say the same thing. So we've built models to basically be able to look after that and try to coalesce this data. And as you mentioned, 20 years of an outage system, things are going to change. You may have completely different cause codes and problem codes and ways of describing things over those years. So this helps us to sort of bring all that together and get a nice consistent view of that information. So yeah, data quality and the data quality actions is a key ingredient.
So I guess with over 30 years of doing this, and initially starting in the OMS world, where it was like, how fast do we get the lights on? We'll worry about everything afterwards. We ended up adding like 30 categories of data integrity checks in there. And some of them are really blatant, such as closing an outage before it occurred, which means now you have negative CMI, customer minutes of interruption. Another one was someone restoring more people on a circuit than actually is on that circuit. So now you think you're in better shape on your outage count when in fact you may be worse. Another one that Paul was talking about on the AI side is that we were working with a very large IOU, investor-owned utility, where we were trying to get the cause codes right, the root causes out there. And we found out that number one outage cause was certainly vegetation because it was east of the Mississippi, But we also found out that sometimes they would say, hey, the outage was caused from weather or equipment failure, like the fuse blew. Well, the reality of it was that when you looked at the restoration notes with AI, it would say, hey, branch hit the line that caused the fuse to blow. So technically that it was a fuse that blew, but the root cause of it was that vegetation may not have been optimized in that area. Or it may have been when they said weather, it could have been wind slapping the branch in there. So with this one utility, we actually redefined the root cause of their problems by 20%. Mike, I'd like to go back to your one question about benefit, price, cost, and benefits. And there was another utility, very large utility, that they made a major investment in reclosers out there in place of fuses that were blowing. And someone, a consultant, went to the Public Service Commission and said, hey, they spent way too much money on this. They're not getting the expected benefits. And so we did an audit using their AMI data, getting back to the AMI part of the data sources and the outages. And we found out that they had avoided thousands of truck rolls. And every time you rolled a truck, the average cost is between $800 and $1,400. So they had to go back to the Public Service Commission and say, hey, we eliminated thousands and thousands of outages, and here's the facts. The Public Service Commission said, great investment. And it was a CapEx investment, which certainly went. So they enjoyed the benefits of a CapEx while they also lowered their O&M. So a bunch of stories, war stories.
Yeah, that's really good information, and I think that speaks very highly. When you're reducing truck rolls, we start talking about sustainability and how we can be more sustainable in some of the things that we do. That's a great example. Wayne, I'm coming your way here next. I just want to make a comment about artificial intelligence. And wouldn't it be interesting if we can use artificial intelligence to go in and improve the quality of the data that we have by, running certain algorithms that say, if you see this, then, this is how you clean it. If you see that, this is how you fix it. Because data is essentially the fuel for the engine of artificial intelligence. But if we can get AI to go back and actually clean the very data that informs the AI, am I missing the boat on that, Paul, just real quickly, or is that someplace where you might see this going?
So what we typically do is on those lines, we keep the source data usually intact, so we can kind of say, here's where you came from, and then augment that data with all this other information alongside it that would say, here's these other, as Ray was mentioning, like root causes, or let's say we're cleaning up GIS connectivity things or stuff like that. We'll show you, here's all the fixes to make, but it's kind of actually introducing a new set of quality data for the utility, so you can kind of see both elements. But
Okay.
that's what we would typically do, yeah.
Good. Okay, Wayne, I'm coming to you. Mark said something when he was talking about his system, and he said he's got 6,500 miles of overhead and 2,500 miles of underground. I'm going to say that's underground distribution. So that's what, 15 kV class, Mark? That really surprised me. I thought in Louisiana, I'm thinking, okay, this has got to be a mostly overhead utility, but he's got 2,500 miles of underground. Are you doing any of your cable inspection work where you're doing the testing so that he's not guessing of the condition of that cable and maybe offering him any kind of opportunity to do some rejuvenation of some of that older cable that he's got in the system? Is that something that you're doing for Mark in particular, or are there other clients that you'd prefer to chat about?
Well, I hate to say it this way, Mike. I really don't know Mark other than, a few meetings we've had. So I don't know if we're working with him because, I look at the whole country and I really don't focus on a particular utility. But your question is excellent. What we know is, and Mark mentioned it, his SAIDI numbers are horrible because of where he's located, and that's typical. What we did, we have a guy who works for us named Darren Byrne. Darren he aggregated 110 of the largest IOUs, investor-owned utilities in the United States, and he made it pretend like it was one utility. That fake utility that he got all the data for had a SAIDI of about 2 hours for the country. SAIFI also about 2 hours and about one interruption per customer. The other thing it showed is that covered about 250 million Americans, if you look at the data that way, as a big piece. And what he then did is separate overhead from underground. And he showed that the SAIDI numbers for overhead are very low, but the safety, the frequency is much higher. Ray mentioned it, Paul mentioned it. You have weather events, vegetation events, all these things happen. Underground cable is quite unique. We have a situation in New Mexico going on right now where there was a fire had gone through. The cables were all underground. So all the stuff that was on the surface burned. So the transformers and everything burned, but the cables are still underground. They're totally fine. They've been tested. So we can test those cables to say, yeah, they're still intact. They're still good because they were underground. Fire doesn't burn underground. So, to say we can rejuvenate underground cables, that's the whole focus of what, Ray mentioned that Southwire purchased his company 3.5 years ago. Well, I work for Novinium, Utelix, Utelix Novinium for, the last, I don't know how many years, 18, 20 years. And Southwire saw the value in, they sell new cable, but they also saw the value in that, yes, there isn't enough new cable being made. And therefore, can we rejuvenate, can we restore underground assets that already exist? So yes, anything that's already underground, if it's aged, even some of the newer things, cables when they were first put in the ground, Mike, I know you're familiar with this, they were believed that they're plastic, right? They're polyethylene or they're rubber. They have EPR rubber on them. It was believed that these would last for 40 years. Back in the 70s, they were lasting less than 10. And it was found that water was the problem. Water was coming into these cables and causing problems. So lots of studies went in to look at how can we make these cables more stable. They looked at drying them with nitrogen gas. If you dry the water out, then the dielectric strength of the cables rises. If, however, you stop drying the cable out, the water comes back in. It actually diffuses right through the plastic. People think of polyethylene as an impermeable plastic, but it's not. And so the water comes back in, water trees grow, and the cables have catastrophic failure caused by water in the insulation. So at Dow, what we developed was a silicone that you can inject into the conductor of the cable. It diffuses into the polyethylene or into the ethylene propylene rubber, and it restores the dielectric strength. It chemically desiccates the water. That's what makes it unique. So we could increase what's already a better, the SAIDI is horrible because the duration of the outage, when you have an outage of an underground cable, you've defined it first and you have to dig it up, potentially splice it or do other things. Some systems are looped, so you can move the normal open and then deal with it later, but you have to deal with it underground. Whereas an overhead, you can just drive by, you can see the cables busted by a branch and have it fixed in just a few minutes. So if you can knock out SAIDI time for underground, that's a huge saving to the utility. And all the work that Southwire does, all the work that Paul and Ray and I have done is all, capital money. So it makes it great that the utility can have a situation where cables are potentially failing and bring them back to like new under a capital a budget for them.
Okay, there's so much in there, Wayne,
I know.
to comment about. So when I advocate for underground, which I like to do, I say, look, we need to evaluate the total cost of ownership over the life of the asset. Oh, Mike, how long might that asset live? And I say, properly operated, a cable today should serve load for 50 to maybe even 100 years if you don't go outside the manufacturer's specifications for how much you heat up the cable. I mean, you don't over operate the cable. And you would agree with that?
100%. Yeah.
Okay. And then I verify that. Let's say I got a 50-year-old cable. Maybe I verify that because I'm testing it to make sure that what I'm thinking is actually true.
Let me stop you there for 1 second, Mike.
Okay, go ahead.
A 50-year-old cable is not a cable of today.
Is not a what?
It's not a cable of today. The
Okay.
technology in cable manufacturing is significantly higher. We're on the 3rd generation of tree retardant polyethylene, and we have much better, clean room situations. We have much better jacketing. We have much better. The cable made today is significantly better than the cable of 50 years ago.
Okay, great
So that's
point.
why
Great point.
I say, yes, A cable made today may last 100 years on its own. A cable that was made 50 years ago probably isn't even in power unless it was rejuvenated with our silicone, and then it will last another 50 to 100 years. But a cable made today is very different than a cable made in 1960 or 1970.
So say that again. An old cable made in 1960 or 70, properly rejuvenated today, could live another 50 years?
Yes, absolutely.
Oh, that's pretty
40 for
cool.
sure. Yeah.
Well, you say that pretty matter of fact. Can you
Yeah,
back
we
that
have
up
lots
with?
of data. The first cable was injected at, this was developed at Dow. It was injected at Dow on January 30th, 1987. That cable's still running today. So what's that, 38 and a half years? It's still running. We've injected 165 million feet of cable around the world. Of that, greater than 99% of those cables are still running. Now you'd say, well, what's the 1%? Why'd you have 1% failure? Because we weren't testing in the early days. Now we can do a barrage of tests. We can do a tan delta test to see how much water is in the cable, and we can do a partial discharge test to see what's the craft work look like at the terminations and splices, and are there mid-span electrical issues in the cable? If you eliminate issues, or if you mitigate the issues at the terminations and the splices, and if you realize that there's mid-span partial discharge, then you probably wouldn't inject that cable. You would mark that for replacement. That's our new process that we're doing. We're calling it test and inject, meaning you test the cable first and you only inject the candidates that make sense. Those cables will probably not fail in our lifetime. The ones that don't pass those tests, we know that there are serious electrical issues with them, and therefore they should be marked for replacement or mitigation work where we can fix the termination or we can fix the splice.
Okay, Ray, I'm coming to you with a question here in a second, but Wayne, one more question. What's your message to the next generation of engineers that are coming up right now about how to specify what I'm doing on a cable? So I'm a civil engineer living in a double E's world, and I believe fervently that we need to tell the next generation of men and women that are designing these systems, you must put some of these things in your specification. You must talk about coefficients of friction. You must talk about using the latest technology. You just cannot design it out of the standards book anymore. That standards book was written like by a standards committee,
50 years.
30 or 40 years ago, right?
Yeah.
It's so antiquated, and we're spending too much money to do it the old way. Is there a way to communicate to the next generation of engineers, hey, you need to specify some of this testing. You need to benchmark where you're at, right at the inception of the cable installation or the rejuvenation, and have a period of, series of tests. What do you think about that, Wayne?
100% agree. Two things. One is when you first put in a cable, you should do a good commission testing, meaning that
Absolutely.
you just can't. And this we see, one of our larger industries is the renewable industry. Matter of fact, I'm going to RE Plus in Las Vegas in just a few weeks. Renewable energy is a plus, And what happens is they try to go cheap, and that's the second thing. You can be cheap if you want to, but you're going to buy cheap cable that won't last. You put more money up front, you do it right, and you never have to worry about long-term issues. Now, that being said, you have something that's fighting you, and that is your commission or your boss telling you, nope, that you're over budget. That you're going to have to find that balance, that happy balance between putting in the right stuff, doing the right tests, and putting in the right cable versus I'm going to put the cheapest stuff in the ground and I'm not even going to measure it.
Hold that thought, Mark Phillips, on the happy place of the balance between cheap and more expensive. Forget about more expensive, better value. Ray, I want to come to you, but Mark, I'm coming to you after that. Ray, so Wayne wants to rejuvenate my cable, but why not just go pull in some new cable? Why not have a capital project and just go pull in new cable and forget about that 30-year cable that's in the ground?
Well, I think it's one of those things that it's do I have enough money in the Tilly? I think there's been a number of utilities that said, hey, let's underground it all. And it's like, well, you're a couple of $1 billion short of doing that, so it's not even feasible. So, that's just not reality. And your members are, if you went to a member or went to a residential customer in the IOU world, they would tell you that, hey, I don't want to pay double for electricity. I'm fine with 4 outages a year. That'll get me by. The other thing is that, the failure curve on laying new cable is really the highest part of the bathtub curve is at the beginning, whereas the implementation of it, that I saw someone, we had our where I was living, they were replacing the cable instead of rejuvenating it, and it's an underground in our neighborhood, and I saw this contractor bending it more than 90 degrees, and then another guy at 185 pounds jumping on it trying to get it underneath the curb. And so he may have hurt some of the value of the wire just putting it in the ground. And then the other part is the connector side of it, and that's why we do the testing and all those things. So the last side story to this is that before I was now part of Southwire, and they were still looking at acquiring Novinium or Wayne's company. And so I went to a couple of companies and said, hey, listen, did you guys ever do any rejuvenation on your underground? And he goes, yeah, we did that a while ago. And I go, well, how did it last? It was just part of a due diligence. And he goes, well, we've never had any problems. And that's been like, 15, 18 years. So it was kind of like a validation to what they were offering. But again, I think it's a financial decision, not to mention that you have customers that will say, I really don't want my yard, dug up. So a number of different things. And the testing that you can realize where your hot spots are versus having to tear up everyone's yard or spend a lot more money underground and with the equipment.
Okay, Mark. Wayne, I'm going to come back to you and ask you what the long-term outlook for cable rejuvenation is before we jump back up to Paul and ask about artificial intelligence. But Mark Phillips, happy spot. Where's the happy spot between the overhead and the underground? You're serving your customers. I can point to you several municipal utilities and maybe even a couple of co-ops that are majority underground, but you're down there in Louisiana and you got a big old IOU down there that likes to build overhead and put it back up every 2 years.
Yeah.
Where's the happy spot?
Oh, the happy spot. So I'll tell you, you have to be strategic, right? Because undergrounding does cost. In some cases, 10 times more than overhead, right? We've actually proved that to our Public Service Commission through some things that we've had to do for them in regards to cost of service, right? But all new residential subdivisions are just about 100% underground now because nobody wants to see the power lines in their front yard anymore or in their backyards anymore. And then there's a public safety concern there as well, right? But the happy medium, or the happy place is, I think you gotta dig into the data, right? If you're gonna plan on kind of converting something from overhead to underground, you gotta, some pain points in your system. You just got to be willing to make that investment. And then, you talk about the costs, of the, like Wayne had alluded to, the cheap cable over the more expensive cable. Well, I can tell you from my perspective that, you get what you pay for, right? If I'm going to put a high quality underground cable in the ground, there's an anticipation that I'm not going to have to go back, right, for 30 or 40 years, if ever. If nothing ever happens, if a tree root doesn't grow into it, if water doesn't seep in, we have some cables that have been in ground for 60 years, that we've never had to touch. Now, that doesn't mean that we haven't had to repair it once, but I think you just have to be really strategic in your approach. But to go back and overhead, underground something you've overheaded already, or re-underground something, like what Ray said. The easiest time to apply the solution is at the beginning, right before the customers move in and before the houses are built. As soon as you build houses in that subdivision, well, then now I can no longer trench that path to lay that cable in. I've got a board in. Well, that's a whole another a whole nother avenue of expenses that double the traditional way that you install underground. So the happy spot is do what's best for you at your utility based off of real life applications for you and how it's worked for you, right? We get the question after every hurricane, why don't we just put all the lines underground? That's the biggest question. Why don't you just go? It's because it costs 10 times more and your rate will be 10 times what it is today if we made that type of investment. So you got to be strategic in your application. You have to have the rate in mind. You have to have the member in mind. So many other different things in mind before you attack such a daunting task, because it is quite the chore to do that.
Okay, Wayne, I'm going to come to you and ask you about the long-term outlook for cable rejuvenation. But Mark, I can't let that one lie. I said I think the total cost of somebody's electric bill is predominantly made up of generation, with T&D being a much smaller, let's say even single digit, up to 10% of the cost of the electric bill. So I go 10x on the cost of underground versus overhead, but that doesn't give me a 10x. I'm not all of a sudden paying 80 cents a kilowatt hour for my electricity. I might be paying 9 cents a kilowatt hour instead of 8 or something like that. So, uh, but at the end of the day, in terms of cost, it's the cost of these outages that we are not able to quantify in the industry. It's the cost of a heavy wet snow or a big ice storm or a tornado or the next big flood that comes through. And what is the cost? What's the lost GDP, and et cetera, et cetera. All those things. I don't think we quantify them, well enough in the industry. The other angle I heard, really interesting, and Wayne, this is going to lead into you, is that somebody made the comment, hey, some of these neighborhoods especially in the newer cities, and I would say like the Phoenix, the Dallas Fort Worth area, the Orlandos, they've been putting in underground for decades now in these residential areas, Mark, like you said. Is it going to be fair down the road to say that we're going to replace the underground cable in those neighborhoods when we still have overhead connections in the older, perhaps less fortunate neighborhoods that exist in our cities? I'll just leave that hanging. That's a very interesting social justice question that we're not probably going to get into today, Wayne. But I see you
Yeah,
shaking
for
your
real.
head.
I'm not answering
You,
that.
you've pondered that for sure, but don't answer that. But
Yeah.
talk to me, maybe even in that context. I mean, I think listening to what you have to say, and I know what's going on in the industry, I think there's a very good long-term outlook for cable rejuvenation. What do you think about that?
Well, I totally agree, obviously. Ray hit the nail on the head. I always tell the story, if I'm the CEO of Microsoft, I won't mention his name, former CEO of Microsoft, and I buy a new car. I drive it for 3,000 miles. Do I do an oil change or do I buy a new car? If I have unlimited money, I can do either. Nobody is that man, right? Except him. And therefore, we have to do the smartest thing for our grid. So the long term, one of the big negatives of cable rejuvenation at the for the 30 years was that we need a stranded conductor to put the chemical down. So that meant solid conductors we couldn't do anything with, but also in the mid 90s, they started putting a strand fill material in it, a polyisobutylene, and that blocked a path for us to get the silicone down. Now, about 4 years ago, we discovered a unique way to inject those types of cables. So to answer your question, Mike, it's really unlimited. No cable on the ground except still a solid conductor because there's no path can't be injected by silicone and can't restore the dielectric strength. What that means is that if you already have an asset in the ground, that it makes incredible sense to keep that asset going, reuse it as opposed to replacing it. Let me give we haven't mentioned sustainability. Let me give you a real example, Mike. So let's say you have a 300-foot length, or let's go 350 because I know the numbers. A 350-foot length of 1/0 aluminum conductor cable that's got 175 mil thick of insulation, right? If you were to look at what is the output of carbon dioxide to replace that cable. So manufacture the cable, transport it to the site, and put it in the ground, replace it. That's the equivalent of driving 3,263 miles. Okay, so we have a facility in Kent, Washington, and we have an operations center in Miami, Florida. That's the equivalent of driving from Kent, Washington to Miami, Florida. Okay, now if you have that 350-foot length of 175 mil thick insulation in the ground already, and you inject it with silicone, you bring it back to like new or better, that's the equivalent of driving 5.9 miles, Mike. That's the sustainability
Wow.
difference between the two. The cost is significantly lower to rejuvenate versus replacing. The velocity, how much cable can you put in the ground in a day? An average crew can maybe get 250 to 300 foot boring cable or trenching cable into the ground. We can do 6 to 10 times that amount of rejuvenation in the same time period. So it's cheaper, you can do it faster, and it's better for the environment. That makes the long-term effect of it, Mike, extremely attractive to most utilities. They're all looking at their carbon footprint, and this is a way of reducing their carbon footprint.
Okay, I'm not going to go commercial here on you, Wayne, but it sounds like a no-brainer. Like, where can I sign up? That just really and truly, and I'm not being facetious. It's just
I know you.
some of
I
these
know
things
you.
are very logical. Okay, Paul, I'm coming your way with an artificial intelligence question, and actually we got this cool question from the audience. Thank you, audience, and here's one. I'm going to read it directly to you, and then let you run with it. Can you please share some digital technologies and real AI tools, not just buzzwords, to improve the reliability and resilience of the grid? How would those technologies work in real life? How big of an impact do they have? That question is from a manufacturer.
Excellent, excellent. Yeah, so a few areas. So number one, we talk about different equipment that can go in place to increase resiliency. Let's say we're talking about cutout mounted reclosures, or maybe we're looking at other things like um, meters or things like so let's take cutout mounted reclosures, for instance. What we need to know is, are those outages transient in nature, or was damage indicated? What happened out there? So using AI, we can go in and process this comment data, which is usually the richest amount of data we have there, and find evidence of those things. We can look at the cause codes that are picked off these lists. As Ray mentioned, a lot of times it's weather, or it's lightning, or it's something of that nature. We can look at other data, potentially even work data and things that were done in the field, bring those together, use AI to process those operator and crew notes to then say this is a transient event versus this is a damage, fixing something from a damage. And therefore, then we can say, okay, now I'm going to reduce X number of outages if I put in this kind of equipment. So that's one area. Another area where AI really plays a role is as we get into more trying to figure out things like circuit segmentation or things of that nature, where we want to make some changes on the network. Well, using things like AMI can help feed that, right? We can take AMI to get a better sense of what are our peaks at these different times of day? What are our peaks at transformers or fuses or things like that, rolling those up. If we use AI to analyze those patterns, we can take these locations where we have multiple types of meter and demands at a location and separate those out for their power factors. So kind of looking at pattern-based things to get a better power factor. Certainly weather is another great area to bring in that data and use AI, because a lot of weather data comes in with a kind of a larger location associated with it. So we can take that weather data, bring that into the system and start looking at temperature, at humidity, at wind, speed, and direction, and applying that to the system. Those are areas where that can come into place. I know a lot of AI goes into analyzing satellite data that can be utilized then to look at fire mitigation strategies. So there's a number of areas where we can apply AI. You brought up a little bit, I know I do want to touch on this too, the sort of the notion of, where do I do the work from a demographics perspective? Well, in addition to things like Katie, which tells us, what are the customers experiencing, or customers experiencing multiple interruptions or long interruptions, those metrics, along with bringing in this external data and assigning and aligning that in with your outages and your GIS data, can help drive to those systems. So we employ AI in different areas to help drive root cause analysis, as well as some of this pattern analysis, and basically helping to align data to the system.
Ray, I'm going to come to you with a question on continue on this AI theme here, but I got a question, Paul, back to you again about the data. Is the data that Southwire is able to bring in, is that data something that you can share with other tools like Maximo or Copperleaf or other types of tools? Slash, can you take data from those other platforms and put them into the analysis that Southwire is doing with, as a data source for your artificial intelligence at Southwire?
Oh, absolutely. So several things. So when we do these solutions and we put this data together and we store not just the data that we sort of process from the utility, but all that data that we augment, we make that available to the utility. So the utility really has this broader sense of data we can use to bring into other tools. One of the things that we also do is it's not just sort of a reporting tool, but a tool that actually gives you, here's the script, here's the things to do. Let's feed those into our work management, our vegetation management, our other systems to actually now go out and execute that work. The other piece, bringing data in, any data we can bring in and align just enriches the system. And what we find is different data sets can give us different insights. That's why that sort of picture with all those data sources, a couple core ones, but then we align that all to the outages. Metering data is really important. As Ray was mentioning, used in a big way to understand what's really going on from a momentary perspective. We're seeing a lot more intelligent devices out there too that can give us things like second by second or minute by minute voltage values and things like that we can bring into the system at strategic locations. So part of it is bringing the data in, but also helping to know, well, where would I deploy this if I wanted to get some real good benefit out of those things?
Yeah,
So,
I would just add that I would just add that a lot of people may say that, well, we could do that manually, and of course you could do it manually, but you may end up spending years trying to decipher things manually. So AI is going to accelerate the program. The other thing is that with AI, if you just did it against one customer's database, right, that's your only test bed. We've been doing it against 10 other databases out there, 15, 20, 30 of them out there, and picking up trends that are going on for maybe utilities that haven't experienced that. For example, years ago, the meters were not lasting as long as they're supposed to last 15 years. The mechanical ones were lasting 30, 40, and everyone thought, yeah, this is going to last 15. And we started seeing breakdowns at 6, 7 years and the trend going substantially up. Well, a newer utility that was putting in the same ones may not even have thought about that was going to happen in the future. So we're kind of giving them some insight about what potentially, can happen down the road. And again, Paul, what Paul was saying, just to make sure you understand, if you put in a recloser and a tree knocks down a pole, a recloser isn't going to help you. But if they found the squirrel out there, or they can confirm that lightning was in that area, or that branches burned off because of restoration notes or customer calls and all that, you now have the right resolution that you can put in, or the right remedy. And I think a lot of times we're finding that you keep on going out there and dropping a new fuse in, but that's not even the right thing to do anymore. You're not fixing the root cause of the problem.
okay,
Sorry,
between
go ahead,
Paul and
Mike.
yeah, between Paul and Ray, you've both given a lot of examples, and Paul used the word any source of data, and Ray earlier you said something, even notes from men and women in the field that might be talking about what they've got in their 30, 40, 50 years of knowledge, and they put that down in writing, and artificial intelligence can tap into things like that even, Ray.
Right, right. Like transformer is spelled 10 different ways. So if you're trying to figure out is it X-formers or transformers or TXs, etc. That's just simple examples. That's
Okay.
more language
Yeah.
interpretation.
So Mark, now I'm going to ask you a question. Now, listening to this, you're an EMC. You got 120,000 meters. You're not the big IOU downstate. are you looking for applications of artificial intelligence? You probably got men and women in your organization that have got a world of knowledge in their head, and you don't want to lose that. But they are going to retire someday, like Ray's retired and Wayne's thinking about it, and they're going to retire. And when they leave, how do you capture that? Is that you think artificial intelligence is going to be a tool for you?
100%. We, as an electric utility, a cooperative, a lot of long tenured employees, 30, 35, some 40, 45 years that they spend
Wow.
their time here, throughout their career. And they leave with a lot of that, like I said, wealth of knowledge, like Ray did when he left Southwire. So artificial intelligence is at the top of our mind. It's actually been inscripted into our strategic plan as something that we are evaluating, whether it's to analyze AMI data, like Paul alluded to, for grid edge information, because that's kind of the wave of AI now, to listening in on the phone when you're having conversations with members, and it's kind of scripting a note for you to apply to that member's account to ensure that you caught all that information, all the way down to digging into your data. The large language model, a co-op perspective, large language model where it's kind of like its own internal company, chat GPT, to some extent. If I want to search some DEMCO data, and it gives me all of those results, because, you know, um, even myself, I mean, I've been here for 20, 24, 25 years now. There's a lot of things that I take for granted that I know that I don't share with others because I don't have it written down or placed somewhere in a file or a folder somewhere. So by, employing artificial intelligence, to kind of handle the redundant task of the day that doesn't really need, um, that can be done by a bot or something running in the background consistently. I mean, I think you have to entertain those things. Something that analyzes your outage information and your operator's notes. That's what Paul and Ray are talking about. I mean, yeah, we have a certain set of calls codes and equipment codes, but those operator notes are just as important. So if we can dive just a touch bit deeper to do a little bit more analyzing, we can get a more desirable result that can help improve the things that we're doing on a day-to-day basis. So if you're not looking at artificial intelligence in some way, shape, or form, well, eventually you're just going to be left behind, because it's here, and it's definitely in our future for sure.
Yeah, I agree that you will be left behind. I'm glad you mentioned ChatGPT. I recently used it. I am always blown away by the amount of detail because it searches multiple databases. It's just not like Wikipedia or your favorite search engine. Multiple databases, and those human notes that are made that are in a file tucked away somewhere. If you can digitize that and take that, then they can tap into that as well. And there's huge untapped value there. So Wayne, I'm going to come to you and I want to ask you, I want to go back to this whole concept of what message do we leave the next generation of engineers, and men and women that are coming into this industry. They want to make a difference. They've been attracted to our industry because of the cool things we do. We're going to build an electric infrastructure that's going to power artificial intelligence. We're going to build it that is going to empower us with distributed energy resources. It's going to prepare for this massive reshoring of business and technology and production in this country. And fundamentally, you cannot do any of it without electricity. So, what message would you tell these young men and women that are coming in?
Well, think outside the box. Don't be, one of the phrases I hate is when I talk to a seasoned professional and he says, well, I've always done it that way. Well,
I hate
I,
that too.
I just can't stand that statement because it drives me nuts. Don't be afraid to leverage what you learned in school. Don't be afraid to attend a webinar like this or a podcast like this and learn something new. Don't be afraid to try something new. I mean, the old saying was, you never got fired for hiring IBM. Well, sometimes that would be a bad thing, right? To do the same old, same old, same old and expect some kind of different result is not the way to go. So, look at the materials, look at the testing. The IEEE has numerous, the Institute for Electrical and Electronic Engineers has numerous guides that will help you to look for the best practices, the best testing, the best materials that are out there, how to find those. And I would say, don't box yourself in and say, this is what this is what everybody is telling me I should do. That's not the answer. Definitely not the answer.
Hey, Mike, were you asking him that question because it took him 10 years to get his PhD? Just asking for a friend.
I did my
Yeah,
PhD in less than 2.5, Ray. I was a studious person,
I don't know, Ray.
Professional student,
I took my
okay.
double E class in summer school and was just glad to get out in 4 years and get married and get on with life. That's what I wanted to do. So, but God bless you, Wayne, for getting the PhD. That's great.
That's
Okay, I got a
awesome.
couple of red meat questions that I love to ask, but PJ probably wouldn't want me to ask them. But I am going to I'm going to go in this direction of joint trench. Okay, I forget I said joint trench. Go back to how should we as an industry rebuild Lahaina? How should we as an industry go in and talk to Southern Cal Ed and LADWP and go into Pacific Palisades and rebuild infrastructure that has been decimated? It's not there. We can start all over. How do you think we ought to do that? Ray, I'm going to come to you with that first, and then I'm going to go to Mark because you two won't get in trouble from Southwire too much.
Well, I'll just give a couple of thoughts here. You got an area that was decimated, and you got to look at the environment that you're dealing with all the time. So, is it hilly? Are there high winds? Is there fire potential? Is it dry all the time, raining all the time? And I think reality of it is you got finite dollars still. So, but there's a lot of new technology out there that you could probably build it back properly. If you think about some of the houses that were built there, they were probably 1,200 square feet initially, no air conditioning, no electric cars in it. And now those things have turned into McMansions out there, as Wayne mentioned, 2 Teslas. So there's an opportunity to build it back right and still economically right. The easiest thing is going to be underground everything, but you may be digging into rocks, and it may be not 10 times more expensive, 20 times. But I think there's enough. There's even wire and cable that can be fire retardant, or you may be able to use. We're working with some manufacturers. One of the things we work with a lot of manufacturers gaining their insights, but you may be able to use concrete or composite poles that are now fire retardant. You can build them up a little higher. So there's a number of technologies that you can apply that probably weren't used 50, 60 years ago when some of those lines were put up.
Yeah, Mark, I'll let you comment. And then Wayne, I'm going to ask you, wouldn't it be interesting, and think about this, and we'll come to you. Wouldn't it be interesting if there was cable in the ground in both of those fire damaged areas and you went back and you tested it and it was still good? Comment on that after Mark. Mark, give us a comment on like rebuilding Lahaina and Pacific Palisades. What do you think about that?
Yeah, I think you have to be, like Ray said, you have to be strategic. You have to evaluate all of the different options that are out there now. Like Ray said, there's so many things that I get pitched on a day-to-day basis from manufacturers or even vendors about the new latest greatest technology, and if you're willing to invest in it, right? Because a lot of it comes at a premium. There's a lot of bells and whistles in our industry right now, and you have to sift through a lot of those things. When I'm thinking about reconstruction, I'm thinking about the reliability and the restoration on the back end, right? It's one thing to put a concrete pole up or a fiberglass pole up, but what if a lineman has to climb it to pick the conductor up, right? Now you've eliminated the opportunity for that to happen. You may have created a long duration outage when it could have been short duration because I have to have special equipment to attack, or a bucket truck or an off-road equipment to attack that pole. So you have to be very strategic. In my opinion, undergrounding is great if you put the right junctions, the right switching cabinets, the right devices in the field to help you analyze where the outage is, or even break down the outage, and so you can try to get the members back on as quickly as possible. Because of course, you're measured by KD as well, which is duration of outage. So I think it depends. I know that might be the status quo question of it just in kind of a generic answer, but you just have to be strategic. while still thinking outside the box, while still keeping the member's best interest in mind, while thinking about the business and how much money you're spending. It's just
Yeah.
it's a real healthy balance.
One of the cool things about this particular power session is I think you guys are out of the box thinkers, and so I really appreciate that. Wayne, have you been asked by LADWP or Southern Cal Edison to go in and look at any cables that might still be in the ground? Wouldn't it be intriguing if after that fire the cables still look good?
Well, we have. I can't answer that question. That's not my area. I honestly don't know. But I will tell you two things, right? I have been out to both of those areas in the past before the fires. They have not only are there cables underground, they have birds, right? Buried underground residential distribution transformers. So the transformer, instead of having a green box on your lawn, it's just a flat plate. And so we know that fire doesn't, heat rises, it doesn't go down. And so there's a high probability that the grid out there that is birds and underground will probably be in very good shape. Now that's California. I've already mentioned at the beginning of this forecast, FEMA came to us and asked us to look at some cables in New Mexico in an area on a hill. And so all the houses, everything burnt off of this hill, but the cables were still intact. They were burned off clean at the ground, but you could splice each of them and at the terminations and put transformers back and work. So to answer your question, Mike, I don't know about Pacific Palisades or LADWP or Southern Cal Edison. They haven't specifically, I don't think, asked us to come yet, but I think there's a high probability that if the cables are underground, the transformers are underground, the switchgear is underground, there's a high probability those cables are still good.
Wow, that's fascinating.
Yeah.
We are almost to the end of this really interesting power session, and I'm going to give each of you a couple minutes to make a concluding remark. Paul, we're going to start with you, and give us some concluding remarks. You are doing fascinating work at Southwire, and tell us what you'd like us to leave this session with.
Sure. Thank you. So one of the things I'd say, kind of on the same topic, by the way, about the rebuild there would be along the theme here is I would look at pulling in the data that they've got. What do we have from the GIS? What do we got from historical outages? We can also bring in things like soil types and ground types and terrain, and lots of other data elements can be brought together. So when you're looking at making the decisions about where to change things from what you had before, what are the good opportunities to do that? Where would strategic undergrounding take place? Where would different kinds of structures make sense? Where would additional smart grid equipment, monitoring equipment, things like that make sense to put in place there? So I think there's some real opportunity to be data driven in your new construction process. And I think that kind of brings me back to sort of what my conclusion would be is that, we're talking about grid resiliency, which really translates, as I mentioned, kind of you can engineer that into the system with this notion of sustainability, reducing all those truck rolls, being able to send your crews to other utilities to support outages because you've taken care of your resiliency at a higher degree.
Right.
Being able to do that, right, and doing that with on an ongoing basis where we're bringing in data, we're constantly enhancing the system, and proving, looking at you kind of goes back to benefits. I can look at your history. What do I expect to get out of doing some changes? And then as Mark was saying, we can also then look at what you get out of it once you actually put those changes in place. So kind of project and measure and then continue to improve. That would be my sort of takeaway I'd look for.
You've got a really fascinating practice there. I'm really glad that I learned about it, and I thank you very much for sharing that. Wayne Chatterton, longtime industry expert. So glad to have you on this session with us today. Tell us some concluding remarks, if you would, please.
First of all, I really appreciate you inviting me, Mike. This has been really fun. I'll say two things. First is if you're not testing, you're truly guessing. I mean, you really need to, the data that Paul and Ray and Mark talked about has to come from somewhere. And testing and getting information on your system is so valuable that it really helps you to make intelligent, informed decisions instead of just swags, right? Silly, wild.
100% with you.
So that's the first thing. The second thing I haven't mentioned is that when we do cable rejuvenation, we do things like map the cable. So we do a time domain reflectometer. We also have GPS coordinates of all transformers, all switchgear, everything like that, that we then feed back to Paul and Ray's system So we actually add to the data that they're having. So it's not like if you do rejuvenation, it's like you're in a box. It's all connected. All the Southwire services are all connected, and so you're actually generating more information. So test what you're doing. Make sure you know what you're doing. And one last thing, I always have a message for everybody is that water is your enemy. Okay, water in the ground, water in the air is causing these cables to fail, is causing your system to degrade, rusting, oxidization of your system, and water is your enemy. Okay, thanks, Mike.
Thank you. Ray Caston, give us some concluding remarks. You have retired from this fun, dynamic industry. You set up a great practice. Paul gets to be the beneficiary. Wayne is a beneficiary. I think all of Southwire is benefiting from this, as well as clients like Mark. So give us some concluding remarks, Ray.
Well, the first one is that before you retire, look at the to-do list that your wife has for you. It's a lot
I'll
more
never
work
retire, Ray. It's never going to happen. Never.
Okay, your 2 minutes is up.
The second item, real quick, is that for our utility friends and partners and stuff, you can build, you can buy, or you can partner. And if you look at the group here, we've all got 30 plus years of experience, and that's certainly helpful. But we're part of an organization of over 100 people within our services group, and so we've got a couple of hundred customers that we've learned from in building best practices, working with the manufacturers out there, trying to find out, okay, what do you have going on, lessons learned, related industries. So our push is that we'd like to partner with our customers. When we put our system in with Mark, he came up with a half a dozen ideas that we could put into the product, and that's what drives it. So the product never becomes obsolete. And so that's that's the way that we work, and that's the way we stay current with partnering with our customers out there. And thank you again for the invite.
Yeah, so good to have you, Ray. Thank you for your insights as well. Mark, I feel like if I was the chief operating officer and I was buying conductor and cable from Southwire, and I heard these guys talk about some of the things they could provide, I'd turn to my director and say, get these guys in here and let's find out where the priorities are of what we can do to improve our system with the following metrics and stuff. So do you feel that way? And I think you do because you're with us today, but give us some concluding remarks and maybe a shout out to Energy Central for hosting this wonderful event.
Yeah, for sure. Thank you guys so much, Mike, for your time. Look, Southwire is a great organization, a great company, and they're out there looking for solutions. They're out there trying to solve problems for utilities. So that is much appreciated because there's a lot of opportunity in our industry right now, whether it be with AI, data analytics, GIS, OMS, cable injection. We're all looking for ways just to make the grid more resilient, more reliable, and we're trying to do it on a budget, right? Not necessarily saying
Right.
you have to buy the cheapest, but you definitely need to consider cost when you're attacking reliability and resiliency, because ultimately it does have an impact on the rate. But there's a lot of top opportunity in our industry. Open magazines, jump on podcasts like this here at Energy Central. Just a great opportunity to learn about what everybody else is doing. It's the wild west right now of AI and innovation. So jump on, or like I mentioned earlier, you might just get left behind. So thank you for your time today, and I appreciate it.
Well, thank you, Mark. And gentlemen, thank you very much for a really, really well done session. And listener, if you heard this today, I would definitely tell your friends, share it, because I think there's a lot of rich content in here that is going to add a lot of value in things that we do down the road. So anyway, great to be with you. Thanks again to Energy Central. Thank you, Southwire, for sponsoring this as well. And PJ, we are turning it back to you.
Thanks, Mike, and thanks, panel. fantastic conversation. And thanks also, of course, to Southwire for making today's event possible. For our audience, look for an email from us for the replay when that becomes available, and take a moment to complete our survey at the end of the session. Your feedback is greatly appreciated, and we'll put it towards making other excellent events for you. From everyone here at Energy Central, thank you for joining. We look forward to seeing you on an upcoming power session. Thank you for attending. This does conclude today's presentation.